Where did we stop? I was talking about REST controller, how to develop REST services. That is what we saw. So we have gone through JPA, Spring Boot, Spring Data. Spring Data, it greatly simplifies the process of interacting with the data source. And we have also created a REST data repository. Repository itself is directly exposed as a web service. Repository methods. We are able to expose repositories as services, REST services. We have gone through that 8 OS and all such things. Today, I'm going to talk about messaging, enterprise messaging. Okay, yes. Let's talk about messaging here. So for enterprise messaging, I'm going to take the help of Spring framework, and we got RabbitMQ. So I'm not using KMS API. So instead, we got the support in Spring Boot through this protocol called as KMQP. We'll be using it. Yes. So first of all, what is enterprise messaging here? That is first thing you need to understand. So what do people think? What is enterprise messaging? Sending messages from a Java application. And what else? Estimate. So messaging is a see what is enterprise messaging? Messaging is a method of communication between software components or applications. The messaging system is peer-to-peer facility. Basically, it says messaging is method of communication between software components or applications. Yes, through messaging, you'll find that applications can communicate with each other, interact with each other. Okay, just a minute, please. Just a minute. Sorry, guys. Yeah, you know, I'm saying messaging is a method of communication between software components or applications, right? But already we saw how to make the applications to communicate with each other, right? How did we do that? Can you people tell me?
RESTful web services.
Through web services. That's right, exactly. Here, Through web services, applications can communicate with each other. Now I'm saying that we can use messaging also for this purpose. I can say that we can also use messaging for this purpose. So, is anyone aware of the difference between these two communications? What is the difference? You know the difference? Let's see. So, what is the difference between web services, okay, and enterprise messaging? You know, we can make applications or application components to communicate with each other through messaging, as I told you people, right? So, let's see what will be the difference here. So, a messaging is actually a peer-to-peer facility. Messaging client can send messages and receive messages from any other client. Generally, here you'll find that applications will be exchanging messages. That is how it works. That is the first point you need to understand. Each client connects connects to a messaging agent that provides facilities for creating, sending, receiving, and reading messages. Okay, yes. So messaging enables distributed communication that is loosely coupled. Yes, messaging enables distributed communication that is loosely coupled. This is very important. You know, you'll see how to use that messaging agents and all. But last point is important that helps you to understand the difference. Messaging enables distributed communication that is loosely coupled. So loosely coupled means what? Let's see. So you see, a component means it is an application component. One of the application components sends a message to a destination, and the recipient can retrieve the message from the destination. Yes, yes. The component sends a message to a destination, and the recipient can retrieve the message from the destination here. So what makes the communication loosely coupled is that the destination is all that sender and receiver have in common. Okay, what makes the communication loosely coupled is the destination is all the sender and receiver have in common here. Yes, that means in the messaging, the two components which are communicating with each other, the two application components which are communicating with each other, you'll find that they don't directly communicate with each other. They don't directly communicate with each other. Yes. Okay. They don't directly communicate with each other. Yes. Then they have a mediator in between. They have a mediator in between. Yes. Just a minute, please. Yeah. What makes the communication loosely coupled is the destination. You see, the destination helps this messaging to be loosely coupled, I can say. The sender and receiver, they do not have to be available at the same time to or in order to communicate. You see, have you noticed it? This is very, very important. This is very, very important. Okay, yes. Here, the sender of the message, who's sending the message, need not know anything about the receiver of that message. Nor does the receiver need to know anything about the sender. Yes. So the sender and receiver need to only know which message format and which destination to use. So what is the common thing between these two application components, the sender and receiver? The destination and the messaging format which they exchange. Okay, the messaging format which they exchange. So these are the common things. So that's the reason why we say this messaging is loosely coupled. And as I told you people, so the receiver of the message need not be available when the sender is sending the message. Okay, yes. Whereas in web services, we have web service client and web service. When a web service is sending the message, when it is placing the request for a service, a resource method or something like that, let's say if your application is not available, if the service is not up and running, if the web service is not, it's not up and running, in that case, what do people think? Here, the web service client will it be able to call that service and make use of the service? No. A web service client, if it wants to use a web service method, the web service should be running. Okay, if it wants to access or consume the web service, that web service should be up and running. If the web service is not up and running, then you know what, here you'll find that here the web service client will not be able to place the request for that web service, will not be able to use the services provided by that web service. Yes. They both should be up and running, web service and web service client. Then only they can communicate with each other successfully. Otherwise, it's not possible. Okay. Yes. Next, yeah, this is the point which I'm talking about. So in this regard, messaging differs from tightly coupled technologies such as remote method invocations, which requires application to know remote methods. Yeah. So actually, your remote methods means it is your SOAP-based services are actually based on remote method invocations itself. So where the client has to know about that the methods and all, it should have the complete details about that method, right? Yes. So unlike your messaging, where the client need not know about that receiver. Yes. See, messaging also differs from electronic mail, which is a method of communication between people or between software applications and people. Okay. Yes. You know what? Here, your emails, it looks similar to your messaging. You see, even in email, what we do, when you send a message to your friends, what happens? First of all, your friend, will it be directly sent to your friend's inbox? What happens? How it works? Yes. Yes. You see, in case of messaging, mails, emails, what happens when you send a message? It will be sent to the mail server. Okay, on the mail server, first of all, the messages will be stored, right? And you can read that message anytime later on. So you need not be available when your friend sends a message, right? So here it's similar, but there is a difference. Generally, when we talk about emails, it is a communication between human to human, a person to person, or human to machine. Yes, you have uh, applications, uh, which can receive your messages, and there are applications which can send messages to persons. That means it can be person, human to application interaction also, or application to human interaction also, but not application to application interaction. Which one? The emails. Okay. Yeah, you see, messaging also differs from electronic mail, which is a method of communication between people or between software applications and people. Messaging is used for communication between software applications or software components. Messaging is used for communication between software applications or software components. That is how messaging works. Yes. Okay. Next, generally, you'll find that in Java, we have Java messaging service, which is the standard API for messaging purpose. But the thing is, nowadays, even JMS is not straight away used. We use frameworks, you see, like Spring, which is providing the support for messaging. I mean, this is a low-level API, I can say, for messaging purpose. Which one? JMS API. Instead, we use, you know, more advanced frameworks and all for messaging purpose. Okay, but for your information, I'm telling people, Java Messaging Service or JMS is a standard Java API that helps you people to create, send, receive, and read messages. The JMS API defines a common set of interfaces and associated semantics that allows programs written in Java programming language, sorry, allows programs written in Java programming language to communicate with other messaging implementations. Yes. So you'll find that JMS API minimizes the set of concepts a programmer must learn in order to use messaging products. Okay. I said this itself is a low level API, but you will find that here further this API usage has been simplified through frameworks and all. Okay. Yeah, we'll see that. Just a minute, please. Just a minute. Yeah, I'm sorry. So, mainly, let's try to understand the advantages of using messaging. Okay. So it is asynchronous and reliable. Here, you know what? You'll find that JMS enables communication that is not only loosely coupled, but also asynchronous, I can say. Is also asynchronous. You know, that means when I say asynchronous, a receiving client does not have to receive messages at the same time the sending client sends them. The sending client can send them and go on to other tasks. The receiving client can receive. That means, you see, after sending the message, actually the sending client, the client application client or application component, which is sending the message to the which is sending the message to the receiver, you need not wait for the receiver to receive the message. After sending the message, it can just go on and continue with its stuff. Okay, so you need not wait for the receiver to receive the message. Yes, that is what happens. The receiver client can receive the message anytime later on. The receiver client can receive the message anytime later on. You can say yes. Now that is the first thing which you need to understand. Next, reliable. The messaging also reliable here. When I say it is reliable, what does that mean? You see, a messaging provider that implements a JMS API can ensure that message is delivered once and only once. Yes, lower levels of reliability and all are available to the application. You can make sure that the messages are reliably sent to the server. Sorry, to the receiver. Yes. Okay. So you see how these applications can exchange messages. You will find that you got a software, a messaging agent, or you can say message server or a message broker. There are many names people use here. Okay, so you'll find that you got something called as message broker, message client, or you can say message server. All means the same. As I told you people, the applications, in order to exchange messages or communicate with each other, they don't directly interact with each other. What they do, you see, in between you'll have this message broker, we say, or message server, which facilitates this messaging. Okay, in between you got this message broker, a message server, you see, message oriented middleware software, which helps the application clients to communicate with each other. Okay, yeah. See, application A wants to communicate with application B. This message, this message broker itself. In the message broker, you'll have something called as destination. Okay? Yeah. Next, further we'll discuss about it. When we talk about messaging, you will find that here we have two different types of messaging. Yes, you'll find that here we got two different types of messaging. One is point to point and publish and subscribe. Point to point messaging model and publish subscribe. Yes. You know, we call them as messaging domains or messaging models. These are two different messaging models which you'll find. So in case of point to point, what happens you see, a product or an application is built on the concept of messages, queues, sender, and receivers. These are the things which you'll see in P2P. On the right side, you got the message. Here, in point to point, you see, you'll have a sender and you'll have a receiver. You see, in this case, you got client one, which is the sender of the message, I can say, who's trying to send the message to the server, to that client two. Client one wants to send a message to client two. Okay, client one wants to send a message to client two. Yes. In this case, what happens? You know, you'll find that the client one will send the message to client two through this queue. The destination is queue here. What is destination, by the way? What is destination, by the way? You see, destination is the place where the messages are stored. Destination, it is actually the place where your messages are stored here, I can say. Yes. Okay. The client one will send a message to the queue. And you see, client two also will read the message from the queue. So where is this destination? What do people think? So where will be this destination here? In the message broker or in the message server. Okay. This queue is a destination. What is queue here? Please try to understand. Queue is a container of messages. So you see the client, this clients, messaging clients, both the messaging clients, they exchange the messages through this queue. So receive sender of the message will send the message to the queue. and receiver of the message will read the message from the queue itself. Okay? Yes. You see, each message is delivered to a specific queue, and receiving clients extract messages from the queues established to hold their messages. Okay? Queues retain all messages sent to them until messages are consumed or expired. Yes. So you see that queue will retain that message till it is consumed or till it expires. Yes. So how the queue will know that application client has received read the message? So you have a receiver of the message. How the client will know that receiver has consumed that message? What do you think? In the image itself, you have the answer. The receiver, after reading the message, it will send the acknowledgement back to the client. Sorry, to the queue. It will send the acknowledgement to the queue. You see, the sender of the message will just send that message to the queue. That's all, and the rest is assured by the destination. Destination will take care of you know reading. Sorry, sending this or delivering this message to the queue. So to that receiver. I mean, it won't push the message to the receiver. It won't push the message to the receiver. So what it does, you will find that here the receiver itself will read the message. The receiver itself will read the message from the destination. After reading the message, the receiver will send the acknowledgement back to that destination here that it has received the message here. Yes, that is how it works.
Sorry, sir. I think I missed something. Is the queue and where will be the message broker here?
That is what I said. The message broker will be in the the destination will be the message broker. The destination will be in the message broker. Yes. So message broker is a software where you will find this message brokers.
Uh, I'm sorry again. Can't we represent it in this diagram? Somewhere in this diagram.
The this queue will be in the message broker. Okay, the queue will be in the message broker. You don't see that message broker here, but this queue will be the message broker in the message server. Message broker means, as I told you people, it's a message server that facilitates this messaging. Yes, the queue will be in the message broker. The destination will be in the message broker always. Yeah.
Okay, okay. Thank you.
So, still, anyone got any doubts? Let me know. Here, now, let's move on. In point-to-point messaging, you'll find the following characters. You see, each message has only one consumer. for a message, you'll just have one consumer, and a sender and receiver of a message has no timing dependencies. As I told you people, the sender can send the message anytime, the receiver can receive the message anytime. The receiver can fetch the message whether or not it was running when the client sent the message. Yes. And receiver acknowledges the successful processing of the message. Receiver basically will acknowledge the successful processing of the message, I can say. That is how it works. Yes. So this is how point-to-point messaging works. Just one message consumer and one message receiver will be there. That's it. Next, we have another type of messaging model or a messaging domain here. You see, that is publish subscribe model, messaging model, or messaging domain is there. Publish subscribe, messaging domain. Yes. So you see, in a publish subscribe product or application model, the clients address messages to the topic. That means here, the destination which is used here is actually called as a topic. The destination which is used here is actually called as a topic. Yes, we call it as a topic. Yes. Destination name is topic, and this destination will be in the message broker again. Okay, the destination will be in the message broker here. Yes. See, you'll find that this publish subscribe model, it works similar to a bulletin board. It works very much similar to your bulletin board, I can say. Yes. Here in bulletin board, what happens, you'll find that bulletin board, or you take this another example. You see, journals. You see, magazines or journals, similar to that example. You'll find that we can send message. Sorry. You see, a journal is published by a publisher, right? So publisher is responsible for publishing journals. Whenever a journal is published by the publisher, you see all the subscribers who have subscribed for this journal will receive that journal once it is published. Will receive the journal once it is published, I can say. Yes. right? So you will subscribe. You can take subscription for a journal. Once you take the subscription for the journal, let's say that journal is published every quarterly. Whenever the journal is published, you'll find that you will receive that journal as a subscriber. Yes, yes, all the subscribers who have subscribed for the journal will receive the journal, right? So here also similarly, you'll find that you'll have publishers. Publisher is an application component which is responsible for generating or producing these messages, and subscribers of the application components which are interested in consuming these messages produced by the producer or publisher, I can say. You see, the publisher of the message will send the message to a destination called as queue. Sorry, topic. Here it is topic. The, the destination is topic here. Okay. The publisher of the message will send the message to the topic. And the interested application components or applications can read that message from the topic. They can read the message from the topic by subscribing it to it, by subscribing to the topic. You see, whichever application component wants to consume that message published by the publisher, they have to subscribe for the topic. Okay, to the topic the messages will be addressed. To the topic the messages will be sent. Okay, to the topic the messages will be sent. So the receivers who are called as subscribers, they have to subscribe to the topic. That is how it works. See, next second point, the system takes care of distributing the messages arriving from a topic's multiple publishers to its publishers to multiple subscribers. Yes. You see, in this case, you will find that here you can have multiple publishers. You see, multiple publishers can publish the messages to the topic. Multiple publishers can publish messages to the topic, and you can have multiple subscribers who are subscribed to that. They are subscribed to that topic who can consume that messages, I can say. Okay. Yes. So whenever a message is published to the topic, you will find that the topic itself will distribute that message or will send that message to the subscribers. Okay. The topic itself will take care of sending this message to the subscribers. Once the topic receives the message from the publisher will distribute that message to all the subscribers of that topic. So we told you people, subscribers can subscribe to the topic here. Okay. Yes. Again, there won't be any direct connection between the publisher and subscriber. Here, the topic is the common thing between the publisher and subscriber. There is a destination, common destination between the publisher and subscriber, I can say. Okay. So the system takes care of distributing the messages here. See, topics retain messages only as long as it takes to distribute them to the current subscribers. You see, once it is done distributing that message to the subscribers, you will find that that message will be destroyed. the message will be destroyed here. That's it. As soon as that message is sent to all the subscribers, the message will be destroyed from the topic. This is how publish subscribe model works. You can check this, you see. So these are the characteristics of publish subscribe model. So each message can have multiple consumers. Each message will have multiple consumers. Here, publishers and subscribers have a timing dependency. You'll find that a client that subscribes to a topic can consume messages only published after its subscription. So what are all the messages which are published after the subscriber has subscribed? Those messages, you'll find that they will be received by the those messages will be received by the subscriber. Subscriber won't receive any messages which are published before its subscription. Okay? Yes. I hope you people got it. So publishers and subscribers, you see, you can have multiple publishers and multiple subscribers here. Only those messages which are published after the subscriber subscription will be received by the subscriber. Yes. Whatever the messages which are published before a subscriber subscription, they won't be sent to that subscriber. Yes. They're lost because they'll be destroyed as soon as the message is distributed to the subscribers. It will be simply destroyed. Okay. It won't be retained. Fine. So this is how publish subscribe model works. Yeah. So this is what first of all I want you people to know. I hope this is clear for you people. So anyone got any questions in this regard, please let me know. Okay. Now how to work with messaging in Spring Boot. In order to work with messaging in Spring Boot, so first of all, you need a message broker or a message server called as RabbitMQ. You know, previously in Java, we used to deploy applications on the application servers. By default, every application server used to have this message server as a message server. By default, every application server used to have a message server part of it. Message server was part of your application server. But nowadays, you see, the deployments and all the architectures for deploying these applications have been changed. So most of the times, people are using microservices for that purpose. So that's the reason why I'm not showing you people the traditional approach of messaging. I mean, using application servers and message servers which are on the application servers. Instead, we are going with the approach which we follow here in microservices. Okay, yeah. Now, basically, RabbitMQ is one of the messaging server, you can say message broker, which is used for messaging. So you can install this RabbitMQ. It is free. You don't have to pay anything for this RabbitMQ here. Okay. I'll show you from where to download this RabbitMQ. You see what they say. RabbitMQ is most widely deployed open source message broker. They say it's a message broker. Okay, it is a message broker. They say yes. You see, you can download and install this message broker. Basically, the messaging is based on AMQP. Okay, let's see that. Yes, AMQP. It's a protocol. You can just refer to it. AMQP is the Internet Protocol for business messaging. This is what they say. Have you noticed it? This AMQP, the full form is Advanced Messaging Queuing Protocol, is an open standard for passing business messages between applications or organizations. Okay? It connects systems, feeds business processes with information they need and reliable and they're reliable basically. So it's the full form. What is it? Advanced Messaging Queuing Protocol, which is used for messaging. How the application clients and how the applications clients can exchange messages using through. Yes, they'll be able to do that through this protocol itself. You can study this. I want you to go through this protocol once. Have some knowledge on this protocol. They gave a case study also, which you can just check once. So how it is used. So basically, primarily, you'll find that messaging is used by the application components to communicate with each other, as I told you people. That means here, what will be the requirement for the applications or application components to communicate with each other? What do you people think? What will be the requirement? Why the applications or application components have to communicate with each other? Yes,
About the status of completion of some tasks or something.
Uh, no, no. Just a minute, please. Just a minute. Yeah, sorry. So now, so far we were talking about the technicalities of the messaging, but the thing is here, why we need this messaging? Yes, purely it's business requirements, I can say. You'll find that one application, sorry, you'll find that as part of the business needs, you see, there may be need to communicate with the partners, business partners. For example, you take, I guess already I gave you an example once. Let's say you have a company, some XYZ company, which produces some goods. Now, this company, in order to, produce this goods, it needs some raw materials. And this, there is some another company, ABC Suppliers. Okay, it's a raw material supplier who supplies raw materials which are required to produce the goods for that XYZ company. You know, now this XYZ company, it has to place the order for the raw materials which are supplied by the suppliers, IBC suppliers. Here, there is a need for communication between these two companies. Okay, at the business level, they have to communicate with each other, and your applications should provide or facilitate such communications. Okay, your applications are supposed to facilitate such communications. Now, you see, every time placing the order manually would be a complex process, and that ABC suppliers may have many such clients. Okay, not just XYZ company. They may have 50 to 50 clients or 100 clients who needs that raw materials, okay, supplied by the ABC supplier. In that case, what happens? You see, they can't take the orders manually from everyone. Maybe they have got an application for it, for taking that orders. But now the point is here, how that XYZ company can send that order or place an order here. You can use messaging for this purpose. So that XYZ company can send that order details as a message to the ABC suppliers. XYZ company can send that order details as a message to ABC suppliers. So ABC suppliers can have a message broker for this purpose, because ABC service may have many clients who will be sending such order details through the messages. So they can have this message broker, as part of their application, which can take the messages, the orders as messages from the clients, from the business partners. Okay, yes, that is how it works. So this way, the messaging can be used. Okay, yes. Now that XYZ company can just simply place the order and leave it to the ABC suppliers. So they need not wait for the ABC suppliers to respond, right? Yes. So or they can send an order confirmation later on. Yes, when it is processed. Yeah. This way, you see, there can be requirement for the business people to communicate with their business clients or supply, or partners. Another example, let's say an online shop and a shipping company. So the online shop is a very big company, let's say, which sells items online. And whenever an item is purchased by the customers, that item has to be shipped to that customer. So that item details, let's say, will be sent to a shipping company. Say it's another company which has got which has got a tie-up with this online shop for providing the shipping services. Okay. Yes. Here you find that online shop application can send that shipping details and the item details to the shipping company, so that the shipping company can deliver that item or ship that item to the customer accordingly. Yes. This way, applications, they may need to communicate with each other. Different applications used or run by different companies, they can interact with each other through this messaging. Okay. Now here in Spring Boot, how do we work with this messaging? That is what you need to know. But before that, make sure that you download this RabbitMQ. I want you people to make sure that you download this RabbitMQ. Okay. Yes. You go to that download option. Yeah. Got this download here, and then if you can scroll down, here itself you'll see this. I'll give you the link here. Make sure that first download and install RabbitMQ. It will be pretty simple and straightforward. Next thing, let's try to create an application for sending messages to that RabbitMQ. Okay, so we'll be working with P2P here. Let's do that. So I'm creating a Spring Boot application for this purpose. So new Spring Starter project. let's say Spring messaging. Let's say this is a messaging sender, let's say message sender. Just a second. Yeah, I'm sorry. You can just make it a jar file. May not be a web application here. It's a message sender application. Now what we need here, first of all, we need that AMQP. Check this AMQP for this messaging purpose. That should be enough. The rest of the things will be taken care. Okay. Click on finish. Just check AMQP. You see, you have a starter. You got a starter for AMQP. Just add the starter for AMQP here. Okay. Okay. Just wait for a while. It has to build that application. It will take some time. Just a minute, please. Yeah, sorry. Okay. So first of all, you see, in this application, I'll show you the starter, which is our Spring Boot starter, which is needed for us for this messaging purpose. Spring Boot starter AMQP. Okay. Now, this application should send a message to the message broker. So what is our message broker? What is the message broker which you're using here? What you people understood? Yes. They're using RabbitMQ. So we need to configure that RabbitMQ here. Okay. Yes. In the application properties, you can configure RabbitMQ. So in the application properties itself, you have to provide the details about the RabbitMQ. You see, string dot RabbitMQ dot host. So first of all, you have to provide that host details. I mean, where exactly this server is hosted, where it is running, RabbitMQ server, it is on the local host. It is on the local host. Okay. Next, the port 5672. By default, your Rabbit, if you install RabbitMQ, it will be running on this port. Okay. This is the default port number of your RabbitMQ server, 567. Next, you see, by default, when you install RabbitMQ, with RabbitMQ, you'll get a username, user account will be there. So always you have to use that credentials to access the RabbitMQ. You can also configure that users and all later on. You can further explore it. See, I'm configuring a user. This is the default user which you'll find in the RabbitMQ, and the password here. Password is also guessed. Username and password both are same. So this is the first thing which you need to do. Configure the RabbitMQ message broker details here. Yes. Next, now, so let's write an application to send the message to the queue. We have to configure the queue. Let's configure a queue and send the message to the queue. Yes. So for messaging purpose, in order to send a message or receive a message, you need a queue. First of all, you need to configure a queue. And to facilitate this messaging in Spring Boot, in a Spring framework, you have messaging template, Rabbit messaging template, which you'll be using. Okay, I'll define a class here. You see, I'll call it as sender, sample sender. Yes. Make sure that here you configure a messaging template, rabbit messaging template. It is from AMQP. Yes. So this is a messaging model provided by Spring. Now just make sure that you ask the framework to inject this template, the rabbit messaging template. It's a predefined bean class, you see. You can ask the framework to inject this template. That is what we can do here. Next, we need to configure a queue. We can configure a queue on that RabbitMQ messaging server. So how can we do that? I will define a method. For this purpose. This method should return a queue object for us. What it does? It returns a queue object. This queue object should be from AMQP. Queue from AMQP. This is a package from Spring Framework. You see? Method name you wish. You can give any name to this method. It's a user-defined method. And just annotate it with this bean annotation. Now you know this concept here of configuring the methods with bean annotation. I'm instantiating that queue class. Pass the queue name. Say my queue. That is the name of the queue. You can give any name. So by creating this queue object, we are just asking the framework to configure this queue, and this queue object represents the queue now. And you see this method, it returns the queue object. By the way, why do we use this annotation at the rate bean on top of that methods? Yes, this indicates that bean annotation indicates that this method, it returns a bean which needs to be managed by the Spring framework. This is the other way of configuring the beans. We saw XML based configurations, we saw annotations based configurations using component annotation, service, or some other annotation. And this is the third way of configuring the beans. Especially we configure the beans which are predefined this way. Using this bean annotation, we configure the beans when that bean is a predefined bean. Okay, because we don't have access to that bean class, right? So we can just instantiate that bean class here and return that bean class object reference and ask the framework to manage this bean. How? By using this annotation at the rate bean. So this method annotated with bean annotation indicates that This method returns a bean which needs to be managed by the Spring framework, Spring container, I can say. Yes. Okay. Now we have configured a bean, I can say. Next, sorry, queue. We have configured a queue. Next, we have to annotate this sample sender with a component annotation, which indicates that the sample sender, is a bean class again. Yes, sample sender is a bean class here. Okay, that is what it indicates. You know what? You will find that the container, when it scans this beans, when it scans this bean, it understands that it has to configure this bean called as queue on the RabbitMQ. It will take care of it. Yeah, your framework itself will make sure that this queue called as my queue is configured on the destination in the RabbitMQ server. Okay, yes, you don't have to do anything in this regard. Next, you can also send a message to that queue. How will you send the message to the queue here? We'll define a method here. You can give any name, send message. In our case, I'll send a string message. Later on, we'll also see how to send other types of user-defined objects also as messages. In the next example, I'll show you. Now, here this method, it takes a string message and sends it to the queue. Template dot, we have a method called as convert and send. To this convert and send method, you pass the queue name. First of all, what is the queue name? My queue. And what is the message? You can send the message. That's it. Don't think that we can only send string messages to the queue. We can send any other type of messages. Yeah. Now, this is just a test message, I can say, which you're sending. Just string message. Later on, we'll send other types of objects also and show you. So, you see, this Rabbit messaging template provides a method. I'm using a method from that Rabbit messaging template. What is it? Convert and send. Okay, you're sending that message. To which queue? My queue. The first parameter is the queue name, the destination name, I can say. And the second parameter is the message which you want to send to that queue. These are the two things which you need to consider here. Yes. So is it clear for you people, all of you? Yes. As of now, for time being, what we did. You see, most of the things are abstracted from us. We got a great abstraction here. We don't have to worry about connecting to that RabbitMQ server. Configuring the queue manually, sending the message also is very simple and straightforward. Yeah. So most of the things are taken care of by this framework itself. Yeah. Now we can write another application to read that message. Okay. Yes. A receiver application. Then we can run them. But I'll do it in the next session. Okay. Yeah. So I'll stop it here today. So in the next class, we'll see how to receive the messages. We'll have a class tomorrow at same time. Please, from now on, use this meeting link for Spring Boot and next microservices also. From day after tomorrow, I'll be starting with microservices. So please attend the class tomorrow. We will continue discussion. Thank you all. Bye bye.